I'd like to welcome Jamie Levy. Jamie is Director of Content Development at Tanium. She has a master's degree from John Jay College in Forensic Computing, and she's co-author of the Technical Forensics Analysis book, The Art of Memory Forensics, Detecting Malware and Threats in Windows, Linux, and Mac Memory. She was one of the principal developers of the Volatility framework, which is the leading open source analysis tool for memory forensics. So please welcome Jamie Levy, who's going to talk about taking memory forensics to the next level.
Thank you for coming out here. So just a little bit about myself that you may not have known, but I guess we've heard most of this. In addition to being a developer for the Volatility framework, I've also worked as a digital forensics researcher, developer, and investigator. I've led many different threat hunting incident response investigations for various companies in the past. I've spoken at a lot of different conferences talking about memory forensics and security and malware. And I also was a former professor for Queens College and John Jay College. So what are we going to talk about? We're going to talk about things from the memory forensics perspective. And just to make sure we're all on the same page, we're talking about the RAM of the machine and not the hard drive. Often you're doing these type of investigations looking also at the disk and network, but sometimes you can only just have the RAM sample and that's all you have for your investigation. So why would we care about memory and what can we recover from there? Well, pretty much everything. Everything that's running on the machine has to be in memory. Everything that's interacting with on the machine has to be in memory at some point. So we can get quite a lot of information. All the running processes, all of the network connections, kernel modules, DLLs, other things as well. Also encryption keys, and basically everything if you think about it. So why does this matter? Or why do we care about memory if we can get things from disk? A lot of times malware can inject things into memory, not utilizing the correct APIs for these things. And so you'll only have this in memory. You're not going to have a pointer from the kernel like pointing to this because it doesn't know about this information. So we do want to look at memory by itself if we do think that there is a threat that has happened to a particular machine. Also, you can have many different applications. You can have sandbox, honeypot, or automated malware analysis that can allow you to get all this type of information. So as you can imagine, there's quite a lot of details about artifacts that we find in memory. And we do have some documentation that can help you get to the bottom of how some of these artifacts are actually found. One of them is a book that we wrote called The Art of Memory Forensics. It's about a 900-page book that covers all the details about artifacts that you can find in memory on a machine and how you can actually go about utilizing Volatility and other tools in order to do these types of investigations. We also have a couple of websites that include documentation. We have a wiki that contains a lot of information of blog posts that are written by other digital forensics researchers, and also academic papers and white papers and various other things. So we have over 250 documents on that wiki, and over 60 different authors have written these. So I'm going to talk a little bit about the Volatility framework because we're going to be using this in order to do the profiling, which we're going to talk about a little bit later. So Volatility is written in Python. It is GPL licensed. You can download the code, you can look at it, you can see exactly how it works. What it does is it rebuilds the state of the operating system, and it allows you to query for various artifacts that are on the machine. We have over 250 different plugins in Volatility, and there's many different features for each of these different plugins, like sample identification. It'll tell you whether or not it's a Windows machine, or what type of Windows machine it is, if it's a crash dump, or if it's a hibernation file. We also have plugins for enumerating processes, DLLs, process memory, and a whole bunch of other things as well. How many people have actually heard of Volatility before this? Okay, so actually quite a few. This is great. So other things about Volatility, it supports many different operating systems. It supports all of the Windows operating systems from Windows XP Service Pack 2 on until the most recent versions of Windows 10. It supports all the different Linux kernels. You can also create your own profiles. We have a repository that contains different profiles for different Linux kernels, but you can create your own as well. And it also supports all of the Mac versions from Leopard onto High Sierra. So let's talk a little bit about the incident response forensics workflow. So in a normal investigation, you have some kind of an event that happens that leads your investigation. It could be something like a user just says, my machine's acting funny. Or it could be an IDS event, or it could be antivirus alert. You have something that tells you something's not right, and I need to start doing my investigation. So at that point, what you're going to do is acquire the machine, acquire its memory, acquire the disk, or et cetera. And you're going to do your investigation, and you're going to try to figure out what is the scope of this investigation, because maybe it's not just one machine that's infected. Maybe that was just the first machine that was infected, and now there's many other machines that are infected as well. So you have to figure out the scope. And once you're able to figure out, okay, well, it's only gone so far, then you have the reporting and you have the containment and remediation of that. So this is what it would look like. You have one machine that's compromised, and you're going to look at this and examine the logs and whatever other artifacts you have on that machine and see what other machines did it connect to. Do I need to look at those machines? Do I need to see whether or not those are compromised? And if it's a fairly small network, you can kind of go through this manually, although it's still a little bit painful because you have to go through each of these machines and then see what do those other machines talk to that are compromised, and figure out all the other ones that are compromised as well. And as your network becomes more and more populated, it becomes a very difficult problem to solve. And so that's what we're trying to actually solve here with profiling. So with profiling, what we're trying to do is make things a little bit easier for the investigator in order to have more digestible chunks of things that are interesting for your investigation. Because you can imagine, if you're looking at all of the memory from all of these different machines that we saw previously, that's a lot of information. It's a lot of processes to go through. It's a lot of DLLs. It's a lot of just crazy stuff that you have to go through here. So wouldn't it be nice if we could just see what are the things that we're interested in? What are the outliers on these machines? And so that's what we're trying to accomplish with profiling. So what we're trying to do is we're trying to have a profile per machine of the things that we're interested in, of the things that actually reside on that machine. Normally, you'd want to have a golden image. This is after you have created your golden image that you're going to copy off onto your other machines that are in your environment. It has all the software that's installed that you want to be allowed in your enterprise, et cetera. So you know that these are the things that are going to be clean and good on your environment. And then you could take a plugin, which I wrote, called Profiler, and what that will do is it'll query for all these information that we're interested in, like processes and network connections and DLLs and other things that we might find interesting. Now, if you're just looking at a machine in one moment of time, you're only going to get part of the story. Why? Because there's other software that's not running at the time. Like, you might have users that they're not using Microsoft Word or something like that at the time that you're making your profile. So there's another plugin that will help with this called Stalker. And what Stalker does is it just watches a machine and it looks for changes. And as there are changes, it just keeps adding these things to this profile. If you don't have time to watch a machine over time for all these various changes, what you can then do is maybe fill in data from the disk, or looking at the files and registry keys and things that reside on the disk as well. So then at that point, once we have our baseline, what we can do is we can compare it to other machines that are on the network and see if there's something that are on those other machines that pops out and doesn't reside within this known good baseline. All right, so before we're talking about looking at memory samples from machines, who can guess what would be the problem if you have thousands of machines or hundreds of thousands of machines and you have servers with like hundreds of gigabytes and 200 gigabytes and whatever of memory? This is not a fun job, going and acquiring memory from all these machines just to see what's going on. So that's where we're going to employ an idea called sampling. And what sampling allows you to do is to look at the memory of the live machine in real time and then just query for various things that are of interest, like the processes that are running, DLLs, injected code, et cetera. As you can imagine, since we're doing this thing over the network, this is a lot less traffic. So just for a process list, it's just 1 megabyte of traffic instead of like hundreds of gigabytes of your server memory, right? So using this idea, what we can do is we can have like a profile of indicators of compromise, things that we know or that are bad, and we could scour the enterprise looking for these known bad things. And then if we see that there are machines that respond to this, then we can do our full acquisition and acquire memory and disk and whatever else we want to do. So the baselines are considered things that are normal. So obviously you wanted to take the baseline from a clean production machine. So what I did was I wrote a library that would work as a container for the artifacts of things that we are interested in. And you can see a list of several things that are contained within this library. There are several other items of interest, but these are the main things that you would look at in an investigation. So there's different things that you can do with the baselines. Like we said earlier, you could just look at only the memory artifacts that you have. So we're able to look at the running state. We're able to look at the processes, loaded modules, DLLs, et cetera. And one thing that we have to consider also is whenever we're looking at injected code and hooks, because a lot of the times this injected code or hooks is going to have references to memory addresses. Those memory addresses change across machines. They change even on the same machine at different runtimes. So we have to have a way to wildcard those memory addresses so that we still have some viable information to compare across these different machines. So how we're able to build these baselines is by using the Profiler plugin. For disk, there's a baseliner InScript. How many people use Incase? Okay, so there's a few. But yeah, you can use this baseliner InScript that I wrote that will actually create like a nice little profile of the files that are on disk. And there's also a regdiff Python file that I wrote that will allow you to look at the registry keys. So as I was saying with the hook comparisons, you have to consider the memory regions. So if you were to look at SSDT hooks, there's an SSDT plugin that you can use from Volatility, and you might get some output that looks something like this, and we don't know whether or not this is something evil. I mean, it looks probably evil because we see like it says unknown, we don't know what that is, and then we see like there's this driver, and we can maybe see what that driver is, and what does that actually belong to. So any guess if it's evil or not? Okay, so actually it's not. I mean, depending on your definition. Um, this is semantic. So these are semantic hooks. And as you can imagine, antivirus works a lot like malware, right? So this is another reason why I wrote all this profiling stuff, was because a lot of times we'd get memory samples and they would have McAfee or Symantec or something installed on there. And you're looking at the hooks like first thing because they know there's malware on there and you're just like, oh, there's these hooks and they're just dangerous and whatever. And then you realize, oh, they just have Symantec installed and this is really annoying. And so you went down this rabbit hole for nothing. So wouldn't it be nice if you could actually normalize this into a way that you could just skip over it and you wouldn't even have to look at that? So how we manage to do this is we do like the code inspection. We look at the disassembly and we see, does this look like something that we've seen before? And you see that there are some memory addresses and things that have been wildcarded here. And the wildcards are these question marks that you see here. And so what we do is we have these YAR rules that are created on the fly when it sees this code. And that way you're able to actually just do the inspection on the actual code that's injected or hooked and verify whether or not it looks like something that you've seen before. So then, once you have these profiles, you can very easily do whitelisting or blacklisting. Known good things, known bad things. So if you have your whitelist, you can just subtract those things out. And if you have your blacklist, you can say that, okay, well, that we found these things and they're bad, and now we need to look at this machine. Some people use Cybox or Sticks. Cybox is now a part of Sticks. How many people use Sticks? Okay, so like a few. Well, the nice thing about both of these is that they have Python bindings. And so that allows you to very easily interact with the rules that are saved in the format in order to do it programmatically within this Python construct. So we know Volatility is written in Python, all these plugins are written in Python, and now we have these libraries that we can import and utilize as well within Volatility. The nice thing about Sticks is that you have this indicator package and you're able to just share it along. I mean, I don't know how many people actually share their indicators. Some people do, and some people don't because they don't want people knowing like what they got hit with, right? So, but you could very easily share these and import it, and a lot of software allows you to import these packages. So we do have a Cybox or Sticks plugin. It's been converted to a Sticks plugin now. And it supports all these various memory items that they have supported within their platform, like process names, IP addresses, utexes, open file services, et cetera. So what you're able to do is import this XML file and then look for indicators of interest. And so here's an example. This is from an older malware sample, but a lot of these malware samples are pretty much the same, where you would have some mutex or something or some process associated with it. And it's basically the same thing, even though this is an older malware sample here, where we can see that there's a mutex that was found on this machine. This WinLogin was responsive because it had some injected code, and these files are also responsive as well because you often find these with that particular piece of malware. So the profiling allows us to see these things that have changed. It's able to see things that have changed over time. We're able to create a list of normal and abnormal things. Wouldn't it be cool if you could get more granularity? Like what type of software is installed on the machine, and what version of software is installed, and what type of malware is installed on the machine, and what version of that malware is. So you can get all this crazy granularity once you have these packages for them. So it's easy to query the machine once you have some mechanism for it, and we're going to discuss kind of the backbone of this profiling code. The way that we'll start out is we'll assume that each machine has a profile associated with it. Now these profiles can even be used loosely. It could be even just a software profile or just a malware profile. It doesn't have to be only for a particular machine, because you define what artifacts are within this profile. So what we're going to use is set theory. We have these different sets of things, and each profile is a set, a collection of these items. So we have all these various items that we're interested in, and there's even more that are just not listed on the slide. We have machine A and we have machine B. As you can imagine, there's an overlap of these machines, all the Windows applications, all the software that's, that they share. So you can see in this Venn diagram, the green area are the items that are shared between these machines, and then the external items are unique to those machines. So what we can do is we can do like a set difference. This would be very useful if you have a golden baseline. It has all the things that you expect to find, and then you just want to subtract those things out. So we actually have the code to allow you to do that. So here you can see that we're importing a golden profile, and then we're importing a suspect profile, and we're creating objects that contain the artifacts for those different profiles. And then the last line, we're just subtracting out the clean items. We don't care about those. And so what we're left with are just the items that were within A and not within B. We can also use the union to combine profiles, and this would be useful for if you're doing the Stalker plugin and you are just creating like this giant profile over time, or you have like several different golden profiles or software profiles that you want to add together. So this will make one giant profile. So we can see that there's a few lines of code here. We have these 3 different profiles, and then we're just combining them here at the end. So they just combine into this one giant profile. We can also have the intersection. So this is useful for finding things that are common between multiple machines. So for instance, if you had all these different malware profiles and you wanted to see what are the things that are common between these different families of malware, you could very easily do that. We see that we're importing all these various indicators of compromise profiles, and then another suspect profile. And we combine all the IOC profiles, and then we have the suspect profile that's created, and we just want to know what are the things that are common between those. And so we're left with that. You can also do symmetric difference. So this is where you want to find unique items, things that are only unique to machine A and only unique to machine B. We don't care about anything in between. So we're just cutting out that middle. So this is pretty cool because we're able to have multiple profiles, and these profiles can be anything. They could just be like all of the artifacts that we found on a particular machine, all the artifacts that we found all across our enterprise. They can only be like, they could be something like just the software version X, et cetera. And we're able to play with them using this different set logic and figure out what are the relationships between all of these items. And you see that most of the time it's just like a few lines of code. These profiles are things that actually live external to Volatility. You can import them into Volatility and use them, or you can play with them offline. And here, this is what we're doing, is just playing with them offline outside of Volatility. So talking about the Profiler plugin, we know that it collects all these different artifacts. It also has options for outputting in different types of output. So there's a text, like more human readable output. There's a JSON output if you like to import things from JSON format. There's also a sidebox or sticks option, and there's also a profile option. And what the profile is actual Python code. So within the library itself, it's actually self-generating code. So you're able to get back something that you can import into Python later as you're doing all these differences. So here's an example of running the profiler plugin. Here we have the invocation of the profiler plugin. We're saying that we want to save this as a Python file, and we're saying save this in profile output. And here we're giving it a class name. If not specified, it just uses some kind of default name. So what we're trying to do is we're building 3 different profiles. We're looking at Symantec in particular in these different states. So one of them is just like Symantec's installed, nothing's happening on the machine. The other one is Symantec is in a scan right now, and the other one is Symantec is actually doing a live update. And all of these items have different files and processes that are associated with them. So here I have a plugin which is just going to just look at the difference between these different profiles. Actually, it's not a plugin. It's just a piece of code. So we're importing these different profiles that we had created previously. We're looking at the processes. So what we're doing is we're subtracting the installed processes. We're not interested in that. We only want things that are useful for the update process that we're having. And so we're going to subtract those out. We get the processes, and we're just printing out this regular code. So these items that we're getting here are things that were only on the machine during this Symantec update. So those are the things that we're interested in. So here's another example where we're combining all of these different profiles into one big profile. And then what we're doing is we're subtracting out a golden profile, which just has like Microsoft, executables and things that are just on a default install. And we're only getting things that are interesting for Symantec. So you can make a very quick volatility plugin out of it. This is all the code that you would need for the volatility plugin. You just import this profiler plugin, and what it's going to do is just the hard work of finding all these different artifacts. And then the rendering is just whatever you decide. In this case, we want things that are only in the profile or not in the profile. And we have these options included either here, like with the F, which is find in the profile, or by default as things that are not in the profile. So we can use this profiler plugin to look at a live machine. We can create a baseline. If you're using some kind of enterprise software to get visualization on your machines on the network, you will have to have some kind of a driver. And there's really only a few options that you can choose from, like fresponse or incase to a lesser extent. And there is open source software, but you really need to test it before you actually deploy it into your enterprise. There's a software called PMIM. It's WinPMIM, OSXPMIM, LinPMIM. You can tell that these are all the different operating systems. So you can find those drivers, and you can use those in order to gain visualization into memory. And then you're able to build your blacklist and your Cybox packages, and et cetera. So here's an example of creating a Cybox package. What we're doing is we're importing these different profiles that we have, Symantec and this golden profile. And what we're doing is we're combining these all into one golden profile, and then we're just subtracting out the outliers into a Cybox package. So that would be useful for just, like you have a machine, you know that you have a baseline that fits that machine, you know that you have Symantec installed, so you have your golden profile that contains all these items, and then you run a piece of malware on it. Like let's say that it's a virtual machine, you just want to get the indicators for it. So you run the piece of malware on it. Yeah, don't do this on your real machine. That's not a good idea. And then you're getting just the Cybox indicators for that. So here's the Stalker plugin, incrementally just finding these new items and adding them to the baseline in order to make your life a little bit easier. It also has an option to alert if you find new items. So by default, it'll just create these profiles for you, and if you want, it can also alert you on the screen to let you know that it's found something interesting. There's also a plugin for Volatility called Hunter, and what that allows you to do is to take to import a profile and use it as an indicator of compromise profile and allow you to highlight the things that it's actually found. And of course, it has all the same different outputs that we have for the Profiler plugin. So here's the Hunter plugin, the same outputs, except the only thing we're doing is we're looking for artifacts. So let's take a look at an example. Jack Crook is, he's an incident response engineer at GE, and every now and then he writes these forensics challenges and he releases them online, and then you're able to write your answers and send them to him, and they're actually pretty in-depth and very nice. So in one case, he had a forensics challenge where there were 4 different machines, and so what we wanted to do was just kind of quickly see what's interesting on these machines. So we had profiles for the same operating systems, and we had our baseline, and we wanted to just see like what's interesting. So here's like a process list from one machine, and you see that that's a lot of stuff to go through. You may or may not be familiar with some of these processes, and maybe some of them stand out to you because you've been doing this for a long time, but maybe not. So if we use the baseline, then we're able to subtract out a lot of things that we know what they are. And if we'd even had a baseline of that particular build that he had from previous instead of a build that we created ourselves, it would have been even more true. It would have taken out even these other items as well. But we didn't have those things running on that machine. So here we're able to just go through just a few lines of code, and we're like, oh, yes, this looks very interesting. So we see that we have these, what is that called again? Why am I blinking out right now? We have this particular process. It's a Windows, not Windows, but what's his name? The sysinternals tool. He wrote this tool that allows you to run commands remotely on other machines. And so we recognize just this command line where you have this accept EULA that you have to type in every time that you run this particular executable. And here's the remote machine, and then we see that it's running some kind of a batch file. And so we're like, oh, okay, well, that looks pretty interesting. And then we also see that there's wc.exe, which is a credential stealer and also manipulator. So that looks very interesting as well. And so these things jump out to us. PSExec, yes. PSExec was what the PS was standing for. So these things are very interesting to us, and they pop out to us, and it very easily leads us into our investigation. So then there's also like various executables that are loaded and references to these executables. And so instead of having to go through like 51 of these executables, we only have like 17 things that we can look at. So that makes our lives much easier. We can see PSExec again, we can see WC, we can see something else, ps.exe, which we didn't really know exactly what that was, but it is actually PSExec. They just changed the name to it. And also, we're looking at DLLs, and you can imagine that there's tons of DLLs that are loaded. And instead of having, like hundreds of DLLs, we only have like 20 DLLs or something. And then we notice that there's one over here that we don't really know what that is. So then we start to do an investigation on that. And then we figure out that this actually is a malicious DLL, and it's loaded within servicehost.exe. So already just running the profiles and profiling code and looking at things that are of interest, we have like a very good starting point. We have a few processes of interest, we have files of interest, a DLL, and there's also some API hooks which we didn't show on here. So this made our lives so much easier, and then we were able to find that there's these things on other machines, like there's on this machine and on this other machine and whatever, and we're able to see this investigation much easier. All right, so let me do a couple of demos real quick. So here's an example where I'm using F-response, which allows you to query machines remotely. You're able to, oh, this is going way too fast. You're able to query machines remotely. You're able to look at their disk. You're able to look at their memory. So I have two machines. There's a Windows machine on the left and a Linux machine on the right. And what I'm doing is I'm setting up my connection to the F-response server on the Windows machine. And then I'm using a Python script, which we have released in order to connect to that machine. And what it'll do is it will mount memory as a device drive, and it'll also mount the disk as device drives, and you can connect to these. So here I'm just connecting to this exposed device. I'm running Profiler. I'm creating a baseline, and it's going to go through all of this and create the baseline for me. And at the end, I have this baseline, which has all the Python code associated with it and the artifacts as well. And so I'm able to use that baseline in future applications. So here's an example of using the Stalker plugin. So what I'm doing is I'm starting up the Windows machine, and I'm trying to create some kind of user activity. So the user opens a browser, opens Notepad, opens some other applications, and just is interacting with that particular machine. In the other window, I'm going to run Stalker, and I'm going to say, show me the new things as you find them, using this incremental flag. And I'm just going to keep interacting with this machine. And it'll take a little bit, but then you notice that something's popped over here. It's found some new processes that it didn't have in the baseline. Because in the baseline, we didn't have anything running. We didn't have the command line running. We didn't have Explorer running and all this stuff. So it took out all the other processes that are running in the background, and it shows me only the new things that are interesting. And then in the meantime, it's going to also query to see if there's other information that it doesn't know about from these other processes that are running. Like, are there other DLLs or executables or other things that are loaded that I didn't know about before? And then at the end, so Stalker will just keep running in a loop. It just keeps running and running and running. And if you want it to stop, you just do a Control-C. And what it'll do at that point is it'll write all this out to the baseline or whatever file you have specified previously. So here's an example of the Hunter plugin. So we have some profile that we've specified previously with IOCs, and what we're doing is we're trying to find these items. So it's querying through all of the different items and seeing if there's anything that it's found. And we didn't run it with any alert, so we didn't see anything pop out on the screen, but we do have a Python profile that has all the information that we were looking for. So in this case, it looks like it was Dark Comet or something running here, and we have these processes that we see. So Notepad, normally, you would have this in your profile, but Notepad's normally not doesn't usually have a parent of MSDCSC. So one of the things that the profile code does is it also looks at parent-child relationships to see what is normal. And in this case, this is not normal, so we find this information. Okay. So here I have my profiles. Oh, let me make it bigger where you can actually see this. So here I have these different profiles. I have I have different baselines. I have also a malware profile. And so maybe I want to see like what are the different relationships between these. So what I could do, I have a little differ script that I already wrote here. And let me make this a little bit bigger. So what we're doing is we're importing the baselines, and we're importing that malware profile, and we're creating one giant baseline, which we see with the union indicator, which is on line 6. So we have our giant baseline, and then we have our malware baseline. And then what it's going to do is it's going to do a set difference where we want only the malware items. We're going to subtract out things that we don't care about, which are in the baselines. And then we just want human readable code here. So when we run it, we get all of these different items. We get the mutexes, the executables, the DLLs, et cetera. If we were to look at the processes, notice there's only a few different processes here. We don't see all the service hosts and things that are normally found on a Windows machine, but we see things that are of interest. We have something called Cisco VPN. That doesn't usually have a command line of MSDCSC. And we see some other indicators of that. It's using command to change the attribute to some other files on there to try to set them to system and hidden so they're not visible to the user if they have those flags set on their settings. But if we were to look at the profile, we notice this is the profile for the malware itself. It has all the other things that you would see on a normal machine. It's just not looking at those because we have subtracted all those out. I mean, look at all this information here. We also have the injected code. Here we're just looking at it in human readable form. We have the YAR rule that's associated with it. We have the disassembly that's associated with it. But if you wanted to, you could actually look at just the raw data. So what I'm going to do is I'm just going to look at just the malfind data within the malware profile. I'm doing a set difference between the malware profile and our baseline. So what I'm doing is I'm just saying, give me the regular output. So I have the same regular output that we saw before. But if I wanted to, I could just say, just give me the data. Oh. Give me, should work. Oh. Oh, yeah, because it's a profile. Oh, this worked earlier. Weird. Okay, but yeah, technically you should be able to just say, give me the data, the raw data itself, and then you can do like in this case, it saves it as base64 data, raw data, and so you could just do any type of manipulations that you want on that. I don't know why, I must have changed something at the last second. Okay, well, any questions about that? I'm going to go ahead and end this. I mean, we see the conclusion is that we're allowed to actually filter through a lot of things very quickly. It makes our investigations much easier. We're able to quickly get to the meat of the problem. And if there's any questions now, you can ask, or you can also email me. I'm freely available. It's just jamie@glida.org, or you can also find me on Twitter, which is just Glida, either way. So, any questions? Yes? So there's been like several different projects that have attempted to do this. Okay, so like there is dementia, which is tried to hide from memory acquisition tools. I don't know if he's still developing this, but there were issues with it in that he didn't know how all the different drivers worked. He knew how one driver worked, and he was able to only thwart things as they were coming back into user space. So like if you were doing a memory acquisition, it would see that you're actually dumping a file to disk, and as it's dumping a file to disk, it would look for the things that are referenced by its malware and just kind of, hide them and delete them. And even then, it didn't always delete everything, and so there were still kind of indicators that something was like wrong. You could still really look at memory and then see like, okay, well, there's something that was pointed to here that doesn't exist anymore. And as far as like spoofing things, there was another project, I think it was called ADD or something like that. And what they tried to do was like create these fake objects that would just throw you off. But when you looked at the objects, they didn't look like real objects because they didn't have valid pointers. Like memory objects are very complex. When you create a process that has tons of pointers to different places, and those objects that it points to have tons of pointers to different places, and eventually it's really hard to spoof all of this stuff. And so eventually you would find these things and you're like, oh, well, it doesn't point to something valid. This thing is interesting. This is a fake entry. So yeah, I mean, there are some malware that try to like mess with things or try to like keep the driver from being loaded. But if it blocks my driver, that machine's suspect, immediately. So yeah, but